Good morning, good afternoon to everybody. Welcome to today's webinar, Integration and Federation, the key to the next wave of network automation. As a quick point of introduction, my name is Morgan Stern. I'm the VP of Service Provider Architecture at Itential. And I also have joining me today, Karin Munalingal, Senior Solutions Architect with Itential, who will be walking you through the Itential demos in real time. Before we get started, I'd like to make a few housekeeping points. Everybody on the call except for Karin and I will be muted. We're going to reserve answering the questions until the end of the presentation, but please feel free to ask your questions along the way by typing them into the questions panel, which you can find at the bottom of your control panel. If we don't get to all the questions on this call, we will answer them via email shortly after the webinar. Okay, let's get started. During this session, we'll start with an introduction of three aspects of Itential's vision for extending the scope of automation. We'll talk about the challenges of expanding network automation from simple use cases to more complex business processes. Then we'll talk about how Itential is addressing those challenges through its innovations in integration and federation. And then Karin will show us demonstrations of some of these exciting capabilities that are available today for Itential end users. For those of you who aren't familiar with Itential, here's a quick introduction. Itential was founded 6 years ago with the recognition that the network of the future, with technologies like SDN, SD-WAN, NFV, orchestration, and mobile edge computing, were going to fundamentally change the way networks were operated and managed. That vision has proven to be accurate. The rate of change for many networks has accelerated, and network teams have seen their scope and workloads expand significantly. Itential's focus is to create software that enables those network teams to deploy sophisticated network automations using DevOps principles in a low-code automation environment. Since its inception, Itential has been deployed by a wide range of customers, including service providers, enterprises, and government agencies. A large part of our success is due to our ability of our software to quickly provide tangible benefits faster than any other related technologies. Itential's approach is based on solving three problems that have traditionally been a challenge for automation. The first is around reach. As we'll talk about shortly, one of the factors that can limit an automation system is its ability to interact with multiple parts of the network, along with all of the OSS and BSS systems. Recognizing that historically it was expensive, both in terms of time and money, to integrate with those systems, Itential's approach is to make it easy to integrate with any system. In fact, many of our customers have been using our online adapter builder and library of pre-built automations to create their own integrations in minutes. The second area is related to data management. Given the complexity of most modern environments, information is stored all over the network, on devices, in multiple OSS systems, on spreadsheets, and EMSs. Itential developers recognized that the importance of providing a way to organize and manage that data without replicating it. Their solution was to use a federation model, which I'll explain in a few minutes. The third area was around ease of use. Itential developers focused on creating a platform that could enable any network engineer to create powerful automations without having to develop code. By using the Itential platform, organizations can take advantage of patent-pending technologies for quickly connecting to virtually any system, organizing the data through federation, and exposing easy-to-use methods for creating powerful automations. With those three areas of focus in mind, I'm going to use an example of a typical network change to show how Itential's innovations are overcoming these challenges and enabling game-changing automation use cases. What you see here is a representation of a typical network change. This could be any kind of change, a change to a router config, a customer service activation, an implementation of a network policy, anything. Typically, the change process begins with planning and scheduling. The team needs to determine what needs to change and when they need to change it. Next, the designers will create a detailed design for the change. They'll determine the specific details and systems that will be impacted in the change process. And they may dip into tools such as inventory systems, IP address management systems, or spreadsheets to collect the variables and all the configuration details that would be associated with that change. Once they complete the design, they hand off the change to the team that will schedule and implement the change. The change might happen during a maintenance window, or it might happen during normal business operations. During this step, engineers need to locate and access each of the devices involved in the change. The devices could be physical boxes, virtual systems, or containers. In a large environment, it might require them to connect to multiple controllers to access those devices. After the change is applied, engineers are going to test to make sure that it was successful. And then finally, the team will close out the change and move on to the next activity. Throughout this process, there might be a ticketing system or some other method to carry the change through the various stages and all of the handoffs that happen between the teams. Also, the format and the structure of the data associated with the change might need to be modified as it moves through the process. For example, the format of the data that comes from an inventory system might need to be changed to match the syntax required by the devices. The percentages I'm showing on this slide represent an average view of the total effort associated with the change that occurs in each of those stages. You'll notice that the actual implementation phase represents only about 10% of the total effort. In most companies that start their automation journey, the focus has been on the automation of the change itself, that 10%. The engineers might write scripts or playbooks to apply a change, and they'll use data from the design team to populate the variables. When you view it in this context, it becomes clear that while this approach might improve the throughput of the implementation step, it doesn't have any impact on the other 90% of those activities that are associated with that change. Itential believes that the key to maximizing business impact lies in automating 100% of the activity. For us, there are two key metrics for automation. The first is around effort. Automation needs to drive manual effort hours out of the entire process. The second metric is duration. Automation should reduce the amount of time for the entire process to complete, that 100%. In the traditional approach, automation will impact that 10%, both in terms of effort and duration, but it doesn't touch the other 90%. So let's talk about what the barriers are in the way of being able to address that other 90%. In our experience, there are four main barriers to automating the 90%. The first is around exposure. Most automation systems lack the ability to expose functionality to all of those stakeholders, the planners, the designers, the engineers, the operations team members, the testers, etc., in a way that's easy to use. Unfortunately, most scripts only make sense to the person who wrote them. So it's almost impossible for somebody in another team to work with those scripts and understand them. The second is around inflexibility. Some automation tools are great at what they do, but they're very domain specific. For example, a tool designed to provide automation of CLI-based systems can't easily adapt to automation in a cloud platform. Or a system that's designed to push changes out to the network may be too complicated to provide tools for planners who need to collect, organize, and manage a lot of data. In order to hit the 90%, the automation platform has to be flexible enough to adapt to the technologies and the scenarios involved in the entire process. The third is around access to data. Complex business processes rely on a large volume of data from a wide range of data sources. Performing activities like determining if there are available resources, or determining which variables to use, or when to perform a change, they all depend on data that comes from OSS systems or from network device configs. In order for the automation platform to effectively perform complex activities, it needs real-time access to that data. This means that the automation platform not only needs to be able to communicate with all of those systems, but it needs a way to understand and manipulate that data into a usable format for all of the steps. This is one area where most automation platforms lack an easy method for accessing and manipulating that data. Fourth area is around limited reach. And this is related to that previous point. In order for the automation system to perform end-to-end automations, it needs to have the ability to interact with all domains in the environment, such as legacy CLI devices, virtual devices, controller-driven environments, and cloud-native environments. Again, while there are a lot of useful domain-specific systems, they're really not designed to perform equally across a diverse range of networking domains. To illustrate what's needed for an automation system to have the reach and flexibility that it needs for end-to-end automation, I want to talk briefly about automation platform fundamentals. Every automation tool in the industry has these three components in common. First, they need the ability to receive triggers for the automations. These triggers are the requests to perform automation activities. Triggers can come from a lot of different places. They can be an engineer kicking off a script, they can be from an API call, they can come from an orchestration system, or they can come from some kind of network event. At a minimum, the trigger needs to provide sufficient information on what it is that needs to happen and what it needs to happen to. This could be something like perform a device upgrade on the following list of routers, or provision this list of customers for the SD-WAN service. Different automators accept different kinds of triggers. Some can support a few, some can support all of them. Second, the automator is the engine that performs the automation. It receives the information from the trigger, then executes the change. During execution, it might request supplemental information from OSS, or it may query the network devices to determine if the targets are in a suitable state to accept those changes. The automator performs the changes on the targets and provides some sort of feedback on success or failure to the trigger. Third, the targets. They're the recipients of the automation requests. These are the elements where the change is performed. They receive the request from the automator, they execute the change, and then they provide some kind of feedback. This model is essentially the same for all kinds of automation activities. They could be for config changes, testing, migrations, updates, whatever. Now let's talk about what an automator needs to be able to address the 100% of the process. On the northbound side, we have the triggers. Triggers can come from one of many possible sources, including network events, ordering system requests, OSS, orchestrators, or engineers when they launch a script or a workflow. The ability of the automation system to provide consistent, secure interfaces for multiple types of triggers enable it to participate in a larger set of situations. We're seeing more and more examples of where users are looking to go to 100% automated use cases, where systems, not people, are triggering those automations. On the east and westbound sides, we have the data sources. These include OSS, databases, IP address management systems, performance systems, fault managers, EMSs. Basically, any resource that provides information to the automator in the form of data, like an IP address, or context, like current network alarms or performance statistics. Similar to the northbound integrations, the ability of the automator to integrate with and to understand the interactions with a large set of data sources will enable it to use that data to make intelligent decisions in the execution of the automation. On the southbound side, we have the targets. This is the network. Targets can be SDN controllers, orchestrators, scripts, cloud platforms, essentially any system that faces the network that the automator can use to execute and interact with the changes associated with the use case. To be able to automate the 100%, The automator needs to have a consistent method for communicating with a diverse set of technologies, and in some cases, across multiple data models, schemas, and interfaces. There are a number of challenges that make this level of integration very difficult, in addition to the ones we talked about earlier. In the networking world, the concept of source of truth is important. People and systems need to know where to get authoritative information. In some cases, this might be a single database, but in most cases, there are multiple sources of truth for different aspects of the network. Device configurations might be stored in one place, while details related to provision services may be kept in another place. Over time, the issue of data quality becomes a concern. If an engineer makes a change to a network element, but doesn't go back and update the database, there's going to be a mismatch. And the database as a source of truth becomes problematic. Second, some systems utilize techniques like data replication to reduce the likelihood of those kinds of mismatches. However, as the rate of change and the size of the network increases, the overhead associated with replication presents its own challenges. Too much replicate generates load, while too little replication creates situations where the data becomes outdated and irrelevant. Another challenge for large-scale integration is related to the ways that the various components store and communicate data. A cloud platform has a completely different data model than a system designed to configure physical routers, for example. Without some mechanism to interpret and harmonize these data models, it's not possible to automate activities that span multiple domains. Within the Itential automation platform, we use the JSON format internally, and we provide multiple tools and capabilities to ingest data, harmonize, and transform that data. We'll show one example of this in the demo later. Finally, the challenge of resource location becomes increasingly complex as the number of connections grows. For example, the trigger may have no idea which controller a particular element is connected to at any given moment. So the automator has to have some capability to organize and track these details. The Itential automation platform addresses the challenges I just described by providing functionality that significantly reduces the complexity of integrating with a wide variety of systems, and then federating that data to organize it for consumption, avoiding any issues associated with replication. So first, let's talk about integrations. In a recent Itential blog post, I talked about how integration drives value. The more systems that an automator can connect to, the more activities it can participate in as part of an automation. By engaging in more of those activities, the amount of total effort, cost, and time that can be taken out of the process increases dramatically. With integration, each connection replaces one or more manual steps that an engineer would normally need to perform. It eliminates the effort and the delays associated with the need to log into other systems, collect appropriate data, and then use that data to perform a task. The gating factors in most environments that prevented large-scale integration have been cost and complexity. Integrations typically require development, both to create and to maintain that integration code. Based on that high cost of integration, organizations normally have to make difficult choices. And their project timelines and budgets force them to prioritize which systems they could afford to integrate with. Anticipating that the future of automation would be driven by integration, Itential designed an architecture that was both flexible and easy to integrate with. Itential users can download pre-built integrations, which we call adapters, from Itential's open source developer hub. For systems that don't already have an adapter, users can access the adapter builder application to dynamically create an adapter in minutes. Having this ability to create integrations in minutes instead of weeks or months has expanded the universe of potential use cases. The diagram on this slide shows the types of systems that users are integrating with, and the logos represent a selection of the vendor adapters that are available now on our developer site. One of the major benefits of having highly connected automation systems is that the information provided by those connected systems can be used by the automation platform to make more intelligent decisions. By interpreting data related to inventory, configuration, performance, and topology, the automation platform can use that information to make choices the same way an engineer would. This is the reason why we say our platform executes network intelligent automations. The more intelligence we can bring to the automation, the more powerful and flexible it becomes, and the more capable it becomes to automate complex use cases. Once you make all these connections, the next challenge is how you organize all the data that's associated with those integration points and enable that level of intelligence. I mentioned earlier that data replication is problematic, but the dynamic nature of new technologies like SDN make the problem even worse. The frequency of changes at the SDN controller layer make it impossible to capture and replicate the state of the network because the state is always changing. This is where federation becomes essential. Federation creates a meta map of the connected systems and the data associated with those systems. Instead of searching for a local replica of the data, the federator knows which system is the authoritative source of truth by consulting an internal, dynamically generated map. When it processes an activity that requires data from one of the connected systems, the automator will query that authoritative source of truth to get the most current information. As part of federation, the system will aggregate and harmonize the data. And when it makes sense, it'll organize the data into categories. In the example shown in the diagram, Itential uses a concept known as a broker to organize data related to devices. Typically, these are devices like routers and switches. Each southbound system has some concept of a device, but they might represent data about devices in different ways. However, there's some things in common, things like being able to generate a list of devices or having the ability to read and change configurations are all common to devices. Using this kind of federation broker enables users to work with common tools, like Itential's Configuration Manager app, regardless of where the actual device is located and regardless of what type of controller it's connected to. Users can do things like generate the list of devices, run configuration compliance, or perform upgrades without having to understand the underlying topology or technologies. Also, northbound systems can make simple API calls to interact with the devices without having to know the location or controller details. Federation enables a global view of resources and eliminates the need to do things like logging into multiple sites or controllers to interact with the network. This makes it much easier for engineers and northbound applications to focus on the tasks they want to perform and avoid getting bogged down in the complexity of the network topology. So now that we've talked about the benefit of extending the reach of automation systems and the importance of federation in a highly collected model, the next historical hurdle that we're addressing is how to extract information from one or more sources and modify it so that it can be sent to one or more target devices. Even in relatively simple use cases, a change to a service might require information from multiple sources, such as an ordering system, inventory system, etc. The native structures and formats of this data will likely be very different. So an engineer would need to determine which fields are relevant and then to which fields that data should map to. Then they need to create a script or some other code to parse the data, restructure it, compose the payload. This is a time-consuming and complicated process. To address this challenge, Itential offers a capability called JSON schema transformations. As I mentioned earlier, Itential uses JSON as its format for representing data within the automation platform. When information is received from a connected system, that data is stored in JSON format. By using a common internal format, we can then utilize tools like the JST Designer to present a no-code model where users can visually create the data mappings. Additionally, they can specify actions to manipulate the data and the formatting for the target. The example I like to use to illustrate the benefits of this approach is around meetings. When you have a meeting that includes people from multiple countries, the meeting organizer has two choices. They can either specify that everybody speaks the same language, or they can use a translator. If it's the first, where everybody's speaking the same language, non-native speakers need to do extra work to participate because they need to adjust on the fly to the common language. In the second scenario, the translator does all the work. Transformations are like the translator. Instead of forcing all the connected systems to adapt to a common information model, which can be really time-consuming and complicated, the transformation plays the role of the translator. The translation happens in one place instead of all the points, and can be easily edited and referenced as changes occur. Karin's going to be demonstrating data transformation during the demo. So let's revisit the business process I talked about earlier. In the previous view, automation was focused on the implementation of the change, which was roughly 10% of the total effort. By utilizing integration, federation, and transformations, the entire process can be automated. Planning activities can be automated to interact with asset management systems, scheduling systems, and project management tools. Then the design activities can be automated to interact with inventory systems and network databases to create the payloads for the change through transformations. Then implementation activities can be further streamlined to reach all of the targets and related OSS systems through federation. Then verification can be automated by integrating with things like automated test systems, performing post checks, or other kinds of verification methods. Finally, the activity can be closed out, and the automation system can provide a rich set of data to document all of the changes, providing tracking, auditing, things like that. It enables teams to demonstrate performance against SLAs, and it also helps them with data that will quantify the benefits of the automation. Throughout the process, the data can be transformed within the automation to make sure that the content and the format align to the target systems at each step of the way. We've seen significant benefits for teams that have used this approach. One Itential customer took a business process for subscriber activation that took 42 days of manual effort down to 2 days. Since this was a full automation use case, the human effort went from 100+ hours down to 0. The only time an engineer needed to be involved was in cases where there were errors due to things like network connectivity issues or device availability. Before I hand the session over to Karin for the demos, let me quickly recap the benefits of integration and federation for automation. First, it provides correlation and simplified management for network functions and elements. Next, it enables global real-time interaction with southbound systems and data. Third, the automation platform becomes a common point of execution for business logic and transformation of data across a large variety of domains. And then finally, exposure to northbound systems and triggers is greatly simplified because the requesters are freed from having to understand the details about the network, like the topology. Based on these benefits, we've seen multiple Itential customers successfully use federation and integration to hit their targets for 100% automation of their business process. Now I'm going to hand things over to Karin, who will demonstrate some of the capabilities that we've talked about.
Thank you, Morgan, and good afternoon, everyone. So today we're going to be covering 2 demos in support of what Morgan just described as part of the core competencies and value that Itential brings to the table. The first one is around device federation, and within that device federation demonstration, we're going to cover Configuration Manager, which is one of our purpose-built application that leverages the concepts around federation as well as integration across multiple different technologies, southbound and northbound. As part of the first demo, we're going to be onboarding Itential adapters, which are integrations, and that's how we communicate with all the end systems. Once the adapters are onboarded within the automation platform, we're going to register them with the broker. And broker is where the intelligence happen around mapping the capability northbound. So we take the complexities away from the users defining these automations and utilizing them. And the last part of that demonstration is going to be us showing you how we're going to leverage the concepts of our federation within our network intelligent automations using the Automation Studio application. The second demo is going to be revolving around the data transformation, which is our data integration strategy, which allows our customers to leverage all integrations within their environment, but at the same time make sure there are schemas and streamlined communication happening without having to write a lot of code around it. So as part of this demo, we're going to have a brief overview of our JSON Schema Transformation Designer application. We're going to walk you through a real-life example, a more evolved example around SD-WAN shipment and how we communicate with multiple end systems and make it easy for our customers in order to map those payloads without having to write code. And finally, also incorporate the concept of transformation within our automations that our customers execute. So with that, I'm going to switch on over to the actual automation platform. All right, this is our Itential automation platform, and what you see in front of you is our application ecosystem. There are tons of purpose-built applications like Config Manager, Service Manager, and Policy Manager, but at the same time, we also have tool sets for our customers that come from different disciplines like NetOps teams and Cloud Ops and software development. Automation Studio is that asset and tool that they utilize to collaborate together to build these end-to-end automations that potentially traverse multiple silos. So as part of the first demonstration around device federation, we're going to dive straight into our configuration manager application. So this is our config manager application that leverages concepts of integration as well as federation. So let's take a look at the devices page. So you'll notice here there's a lot of virtual physical devices that we're federating currently across a distributed deployment of a service orchestrator. In this case, it's NSO, it could be Blue Planet, NEC, HP, etc. So these are 17 devices that we're actually federating dynamically without having to store the inventory data somewhere, right? We want to make sure that we're yet not another system that keeps a stale set of inventory. So as part of this demonstration, what I'm going to do is quickly dive into this device core ATL0, and you'll notice it understand who the actual management system is. In this case, it's NSO, and I can perform load configuration as one of the action on this device, right? So as a user, you don't have to understand when I perform this load config, which orchestrator or DevOps tool it's actually going out to. So in this case, it's utilizing NSO, and I perform this live on that device. It's a virtual device. So at the same time, I can perform backup comparison, or I can take a brand new backup within this actual application. So everything that I'm clicking on right now also is available as a drag and drop asset within our Automation Studio, because we want to make sure that our customers have the ability to define zero-touch automation instead of leveraging GUI all the time. So in this case, I have the capability to look at this particular backup and compare it with live config from the device, or I can compare that against one of the older config older backups that were taken in the past, right? So you'll notice this is a side-by-side diff. So you can do this programmatically within our automations, or you can have this, have your operation engineer team come in and do this visually and make sure that the device has the configuration that it needs in order to perform. So these are some of the basic operations that you can actually do utilizing the applications. But if we quickly go back to the screen, you'll notice there are 17 devices. The next part of the demo is we're going to onboard Automation Gateway, which is an Itential powered application that leverages things like Terraform and Ansible and Chef and Puppet in order to federate those devices. At the same time, we're actually going to also onboard an EC2 adapter where we're going to deal with cloud constructs like VPC as a device. So let's go on and do that, right? I'm going to quickly dive into our services page, and you'll notice these are all the adapters that have been onboarded onto this particular platform, right? So these are 4 different, actually it's 4 EC2 adapters for each region. So now I can federate across every region that Amazon rolls out, and I have the ability to now fetch all the VPCs and subnets, etc., across these. So what we're going to do right now is we're going to go into the West adapter and associate that with the device broker, right? So there are going to be technologies that have the ability to provide things like compliance and service orchestration, etc. So based on that, you have the ability to associate a specific integration into one or many of these brokers. So in this case, we're going to be dealing with the EC2. So I'm going to say I'm going to add the device broker, associate the device broker with this specific adapter. And once I'm done, I'm going to go ahead and save that. And at the same time, I will go to the automation gateway and do the same thing. I'm going to associate the automation gateway with the device broker. And what we're going to do is once I save this, we're going to quickly flip on over to our configuration manager application where it would show the device. So without having to write any code and strictly by associating these integrations that we onboard to the actual device broker, I can just click on this refresh button and you'll notice it went from 17 to 28. And why that is now we're federating devices, whether it's virtual or physical, across automation gateway, which leverages things like Ansible or other DevOps tools in order to pull that information, right? So anything that I did previously on the Core ATL 0 device, I have the ability to do the same set of actions agnostically across all the devices managed by DevOps tools as well. More interestingly, if I actually expand on how many devices we show on the page here, in addition to us federating devices from the orchestrator DevOps tool, we are also federating VPCs, and this is a cloud construct, right? You have VPCs, and we're treating that as a device. So now if I actually open up this VPC, I actually get a status just like any other device in the network. At the same time, I can load configuration, and previously we saw that the device actually propagated CLI or native config. In this case, it's actually a JSON object, right? This is what the model looks like for what a VPC is within AWS. So you will notice I can take backups. I can go to the backups and actually compare this particular backup to the one before, right? So I can compare this to the live one. So you'll notice there's no difference, but at the same time, I can load that up, do the backup comparison previously. So you'll notice these were all the route table entries associated previously, but in the current version of that VPC, we have deleted those routes. So you'll notice how the application is very agnostic to the southbound technologies, and that is why our customers have the ability to pick the right tool for the right job without having to do a lot of rework northbound if they have a vertical solution in place. So these are some of the concepts, and as I mentioned earlier, everything that I'm clicking on here is available as a drag and drop asset within the Automation Studio, and that is exactly what I'm going to show you next, right? So before I actually go into that, I want to mention one thing. As you notice, within our adapter page, there's a lot of these integrations built in. So similar to how I did it for an EC2 adapter, I could do the same thing for an Azure adapter or a Meraki adapter. And as soon as you start associating some of these integrations into the device broker or service broker, we will start federating things like access points from your sites or Azure VNets from your deployments, etc. Right? So that is where the real value is. We want to make sure that we provide the scale and the speed at which our customers have the ability to perform these automations on top of multiple different orchestrators and controllers and DevOps tools without having to build specific scripts and understand that, hey, today this particular device is managed by Ansible, and tomorrow it's managed by Blue Planet, etc. So with that, I'm going to quickly dive into our Automation Studio application. And this is where multiple disciplines come in order to actually build these end-to-end automations that Morgan referred to in order to gain that ROI across 100% of the automation, right? So let's quickly take a look at this particular automations that we have already pre-built. In this case, I'm going to quickly zoom into it. So all the green tasks that you see in front of you are automated tasks, right? And most of these are network intelligent tasks that Itential provides out of box because we have the ability to understand modeling languages like Yang and Tosca and YAML. In addition to that, we have the capability to do the federation across these technologies, right? So you will notice run command template that allows you to perform pre-check and post-check. In this case, once the user defines how many pre-check commands they want to run on a device, they don't have to worry about figuring out whether those are going to be executed by a DevOps tool or a service orchestrator, right? Itential takes care of that using the broker layer, right? And at the same time, if you wanted to perform a backup on a device, you could do the same thing. So as I highlighted before, on the right-hand side, these are all the integrations that have been onboarded. And this includes things like ITSM systems and things like event management system, service order management system, and all the network-facing technologies. So there's a long list here, and few things that we're going to focus on is the configuration manager, right? That's the application that I demoed earlier. These are all the tasks and actions that are now available in a programmatic fashion. So if I wanted to back up an actual device, I could drag and drop that within my automation canvas. And when I actually open that, you'll notice I basically just provide a name of the device, and then Itential does the rest with respect to using the right tool in order to fetch that device configuration and make that backup available to the user northbound. At the same time, you will notice there are tons of other folders available on the right, like Meraki. So as you start onboarding newer integration within the platform, every single API provided that vendor is now available for use within the automation canvas. If I wanted to bind network, I could easily just drag and drop that particular action provided by Meraki and utilize that within my automation, right? And as Morgan talked about our capability to integrate with different technology with different interfaces, this some of these boxes are API driven and some of them could be scripts. So at the same time, you'll notice within this specific automation, we're leveraging out-of-box modules provided by Red Hat, right? But we have customers that potentially have devices being managed by script because there is no modules available for it. So in that case, you know, we have customers that have written scripts that you can absolutely integrate as part of your automation strategy. So if I wanted a shell script or if I wanted a Python script, I could actually build an end-to-end automation leveraging all sorts of assets available within an organization or the ones that they're going to be investing going forward, right? So that was a demonstration to show how customers have the ability to leverage concepts of federation and build future-proof solution. So when you have devices being managed by one system and they swap on to the next tomorrow, you don't have to modify the actual automations that you have built, right? And that's where the real value comes into picture, is faster time to market and reduction in a lot of retest and rebuild as you start investing in new assets. So that was our first demonstration. As part of the second demonstration, we're going to quickly dive into our JST Designer, right? This is our JSON schema designer. And before I jump there, you know, the segue here is, as you saw, there's a lot of integrations that our customers onboard within the automation platform. And because of that, it becomes very critical and essential that Itential has provided a new tool that allows you to do data transformation across these sets of technologies, right? Some of these are older or legacy technology, and some of these are modern that adopt newer concepts like JSON or have a more defined data structure. So as part of the next demo, I'm going to show you how we're going to make it easy for our customers to leverage these integrations that come across multiple domains, but at the same time have a standard way of allowing the communication to flow. So when things like API data structure change, you don't have to go do a lot of rework in code. You can actually make that as a configuration change. So with that, I'm going to quickly switch on over to our JST Designer. And this is the tool that is actually available from our dev side. So customers have the ability to leverage that as of today. So in this case, what you see in front of you is a blank canvas. In order to explain and provide a brief overview, I'm actually going to pull up a quick little example of how our customers have the ability to take multiple incoming schemas from different sources of truth and get the results that they need. So within this specific example, on the left-hand side, you'll notice we have potentially an array of first and last names coming from, things like an Excel or a database. And at the same time, we have the name of the company. And the result that we actually want is an array of email addresses purely created from two different sources of truth here, right? On the left-hand side, we're going to actually leverage the first and the last name, and we're going to combine that with the company name in order to automatically generate the email addresses for the next system to consume and potentially send invites to, right? So in order to do that, one could, write a script or ETL, etc. But in this case, we really want to make it easy for our customers to utilize the same concept of easy to use drag and drop in order to gain this and provide an advantage where you're not going back and writing or rewriting code when some things change like requirements. So in this case, we're going to take the name of the employees, and we'll quickly dive into this map function, right? So when you go into a map function, we're basically saying we're going to take the first name and the last name and associate a company and create an actual template literal, right? So when I hover over this particular task or a function, you'll notice it clearly tells our customers what it can do, right? So if I quickly dive into the template details, we're taking the first name and last name as a parameter and company as a parameter, and we're generating dynamically those email addresses, right? So this is how easy. So tomorrow, instead of having a period here, you can add underscore without writing a lot of code, right? So when requirements change, we want to make sure we give you the ability to quickly adapt to those changes without having a lot of software development in play. So let me quickly go back to the main screen here, and we'll show you how we can easily test these transformation, right? So what I'm going to do is I'm going to run this actual transformation, and because you have a schema defined for your input, which are the employees and the company name, I'm going to quickly add my name, my first and last name, and we're going to watch it run through, right? And Itential, and we're going to say extract output, validate the incoming, and this is where the real value is, right? As we start going towards machine to machine automation, we want to make sure that we're also aggressively validating all the inputs coming from different systems so you can catch these errors up front. So in this case, I'm going to go ahead and run the transformation, and you'll notice this is a result. So it basically took my first name and my last name, and it combined that with a company string and created this email address, right? So now this actually becomes a reusable asset that you could utilize within your automations across the board. And if folks want to make changes, like if I went back in here as an example and said, hey, as a requirement, I don't want a period and I basically want a underscore, I can easily just update and rerun the test on our main page. And you'll notice it went from current dot monolingual to current underscore, right? So this is how easy it is for our customers to quickly change and adapt to these requirements. And on the right-hand side, you'll notice these are all the methods available for you to take advantage of. So before I dive into the Automation Studio and show you how this would get leverage within the automations, I'm going to quickly discuss a more involved example around SD-WAN device shipment, right? So this is another example where you have multiple sources of truth. In this case, you have a warehouse database that is providing these sets of information and a customer portal that actually provides all the information about that customer. And on the right-hand side, we have FedEx shipping API that requires a specific payload. So you'll notice there's a lot of straight mapping that is happening. So if I wanted to map product type straight into the service type, I could very easily do that. But you'll notice some systems actually provide, in this case, the customer request has distributed the address in 5 different fields. So you'll notice the city, the country, the county, the zip code, etc. However, my FedEx API requires that in a single address line, right? So in order to quickly do that and adapt to that requirement, we have the ability to drag and drop a template literal function and map all the incoming values, and the outgoing of that would be a single string that gets provided to that API, right? So this is how easy it is for our customers to work with this specific tool. So let's say you have actually mapped the IMEI to the package ID, right, as part of the transaction process. And tomorrow, FedEx actually modifies their data structure and changes the package ID from a string to a number, right? And these things happen as you have vendors innovating on their end. So once I do that, you'll notice that the link actually disappeared is because you cannot map a string into a number, right? Now all of a sudden your script fails or your automation fails. So now what you can do is with this actual tool, you can actually convert the number or the string into an integer, right? So I can very easily drag the IMEI, which is a string provided by the warehouse system, and then map the integer directly into the package ID. So this is how quickly you're able to adapt to any of the changes that are happening across your vendor ecosystem, right? So this was a more evolved example of how customers utilize it with respect to having multiple integrations involved from end-to-end automation perspective. So as part of as the last part of this demonstration, what I'm going to do is jump back into our automation studio and actually show you how these JSTs or these transformations are being utilized. So let's take a look at the SD-WAN example. So in this case, you'll notice I have a simple flow that allows you to incorporate a JST, and we're going to take a look at the results. But at the same time, let's say you create multiple JSTs across your integration ecosystem. You'll notice it's easy for me to quickly drag and drop that as an asset. And because it's reusable, multiple folks within the organization can now leverage it instead of reinventing the wheel. So when I double click on it, it basically asks me for a transformation ID, and it will automatically understand what inputs are required and what it's actually going to output. So in this case, I've actually onboarded the example that we just looked at for the SD-WAN shipment. And you'll notice these are the two inputs, right? The customer request and the warehouse information. In this case, I'm providing this statically, but at the same time, our customers have the ability to choose where that particular set of information comes from. So it could come from invoking an API, it could come from executing a script, etc. But once this specific JST actually gets the data, it will perform the intelligent operation and give you an output required for the FedEx API. So let's go ahead and kick this off and we'll quickly walk through what happens, right? So I've kicked off the automation. Let's take a look at the actual execution. So in this case, let's take a look at the task, right? This is our JST task. You'll notice, Itential will audit all the information, how long it took, etc. But in this case, this is what I had provided as part of the incoming, right? This is the warehouse information that we got, and this is the customer request information that we have. So you'll notice if I start scrolling, all the address and city are separate input values. And if we go to take a look at the result in this view, you'll notice the transformation went through and actually created this payload strictly by mapping and performing intelligent transformation. So it actually created this address line purely based on the template literal function that we had included as part of our automation, right? So this is the power of integration, federation, and transformation that our customers leverage in order to accelerate their digital transformation. And this was the end of the demonstration. What I'm going to do is I'm going to start the Q&A session now.
Okay, as a quick reminder, you can ask your question in the question panel at the bottom of your control panel. We already have some questions that come in, so let's start in the remaining time to try to get through some of them. First question is, this appears to be a layer of abstraction that can be implemented above other layers of abstraction like SDN or DevOps tools. Yeah, that would be an accurate view of things. I think what we have come to realize is that those lower layers, similar to what you've described, are really good candidates for us to be able to provide that more end-to-end process automation on top of. So SDN controllers know how to execute a change. They don't always know when to execute the change or what change to actually execute. But if you look at the way that the processes are, in general, they're very consistent, right? When I'm doing something to one target set of systems, I'm generally using the same high-level steps to do that. So what we're doing here is as you stated, we're providing that layer of abstraction. We're also providing that intelligence to be able to know which of those southbound systems to talk to and how to format the payload such that they can do their job and do the things that they want to do. Another question was, is there a way to preview or model a proposed change before you commit it? Like if you want to be able to determine if it's going to overload any of the required resources. There are a couple pieces to the answer of this. Yes, absolutely. We provide a lot of different ways to preview the changes. I think Karin showed an example, but you can build into the automation for those steps where you want to make sure that the situation is what you want it to be. You can put in a manual step to do a preview. Additionally, one of the things we didn't show today, just due to time, was we have the ability to do analysis on output of a previous step, run some rules against that, and then use some rules logic to determine, is it okay to do this? The second part of the question around modeling, we don't position ourselves as a modeling tool, but what we do is provide the ability to submit a request out to a system like a topology system or a performance system with the appropriate information so that that system can then run the model, determine if there's any constraints, and then provide information back to us. So we do have a couple of different mechanisms. One is internal. The second would be then to work with some of those interconnected systems to be able to determine if all of the constraints are satisfied or if there's any other potential impact that would be problematic around a particular change. And I think that really underscores the point I was making earlier around the more systems I connect to, the more value I get, the more cool things I can do like that. Next question would be, and I think Karin, I think you talked about this a little bit. If I already have Ansible scripts, how can I use Itential's capabilities in conjunction with our current Ansible efforts? I think we showed this in the demo, but just to kind of elaborate real quickly, we are big fans of working with folks who are working with Ansible. I think that they've made some really major steps in starting to automate pieces of their network. What we're doing here is enabling them to leverage all of those assets, but then to add that additional level of intelligence and that additional level of automation on top of that. So similar to my comments around the controllers, the Ansible scripts generally are really good at executing a job very quickly, provided you tell them when to do it and what to do it to. And so what we're doing, and as Karin showed, is we're ingesting visibility into those Ansible assets so that you could then, as part of your workflow development, just integrate it and go. Okay, folks, we are at time. I want to be able to say that was the last question for today, and I want to thank everybody for your participation and for the engagement. A number of questions came in that we didn't have time to answer, and we'll reach out to you all as follow-up activities as part of email. Karin and I hope you found this webinar to be insightful and useful. If you have other questions, you can feel free to contact us on the email listed. You can visit our website. We've also provided the web address for the developer site so that you can see some of the assets that Karin mentioned. And Karin and I want to thank everybody once again, and we hope everybody has a great day. Thanks.